Okay, here I messed up. It's supposed to be 9%. Hold on. Let me write down. It's supposed to be 9%. Okay? Therefore, find the probability that all free people, meaning and first and second and third, have type B blood, which means for each one of them it's going to be 9% chance, right? So which means what we're going to do, 0.09 times second one, also going to be same thing, 0.09, and then third one 0.09. So how much it's going to be? 0.09 times 0.09 times 0.09, and we are getting 0.000729. So 1, 2, 3, 4, 5, 6, it's going to be 0.000729. One thing I need to tell you, I forgot to tell you earlier, when you are doing solving problem in statistics, you do not round the problem, because see how 6 digits decimal notation, it can affect the result. So do not round it until the final answer. Okay? Next, find the probability that none of them, it's very important, none of them, if all three are each one of them is 9%, then none of them, it's going to be 1 minus 9% is 0.09, right? It's going to be equal 0.91, and then 0.91, since it's going to be free, it's going to be 0.91 times 0.91 times 0.91, and the result is going to be 0.91 times 0.91, and we are getting 0.753571. So here it is. Answer is going to be for B, 0.753571. Okay. Question number 6, C. So here they want to round till 3 decimals. Okay, then it's going to be 0.754. 0.754. Okay. Next, find the probability that at least one of them, very important, at least one of three has type B plus. For this case, what we do, we take 1 and minus the 0.754. Okay? 1 minus 0.754 is gonna be 6 here, 4, and then 2 point. Okay, 0.246. All right. And question number D, which of the event can be considered unusual? Which event can be unusual? It's the one that's in A, 0.000729. Here it is, because it's less than 0.05. Let's say 5%. It's falling into unusual case. Okay, question number 7. In recent years, about 39% of all infants born in country were conceived through in vitro fertilization. And about 24%, let me see, 24% resulted in multiple births. Okay, so let's find out question A. Find the probability that a randomly selected infant was conceived through IVF and was part of multiple birth. So 39%, we have about 39%, here it is. 39% is 0.39, right? And 24%, here it is, this one, 0.24%. So first, 39% born in country were conceived via IVF. Of the IVF deliveries, about 24% resulted in multiple births. So this is going to be times 0.24. And the answer is going to be 0.094. So 0.094. Now, question B, the probability that randomly selected infant conceived through IVF was not part of multiple birth. So was not, meaning this is going to be complement. What we're going to do, you did to 1. The multiple birth was 0.24, right? So 1 minus 0. It's not multiple birth, so it's a complement. Minus 0.24 is going to be 0.76. This is B. Moving to C. What is unusual for all this? Would it be unusual for a randomly selected IVF cycle to result in pregnancy and produce a multiple birth? No, it's not gonna be unusual, because the probability is not less than or equal 0.05. Okay? Question number 8. According to a study, 80% of K-12 schools or districts in a country use digital content such as ebooks, audiobooks, and digital textbook. Of these 80%, 6 out of 20, so let's mark down here, we need this 80%, and then we need 6 out of 20 of this 80% use digital content as a part of their curriculum. So we need to find the probability that a randomly selected school or district uses digital content and uses it as a part of their curriculum. So 80%, we have part of is using 80%, which is going to be 0.8. And the other part is using 6 out of 20. So times 6 out of 20. So it's going to be 0.8 times 0.3. And the result will be 0.24. So 0.24 is the answer for the first question. Actually, that's the only question for question number 8. Moving question number 9. A physics class has 40 students, okay? Of these 18 students, so 18 out of 40, right, are physics majors, and 16 students are female. Okay. Of the physics majors, 5 are female. All right. Find the probability that randomly selected student is female or major physics major. Crucially important note, when it says female or physics major or between two events, you always end up with addition. If it says female and physics major, you end up with multiplication. Up to now we were doing multiplication because it was and everywhere. Now it's maybe it won't literally says and, but you can fit the and, the word and in the explanation. Let's say if it would say all 3 students, right? You would understand, and first one and second one and third one, like that. Okay, so 18 students are physics majors, so 18 out of 40. So since we have or, we need to add. And then 16 students are female, so plus 16 out of 40. Of the physics major, 5 are female. Now what's happening? These 5 belongs and females and major, which means with 5 student, we count it twice. Once we count it in a counting amount of students, and the other one in amount of females. So not to duplicate, we need to subtract 5 out of 40. And you will have similar case in the video lecture. So that means 0.45 plus 0.44 and minus 0.125. And the answer is going to be 0.725, which means 0.725, that means 72.5% of selected student is going to be female or physics major. Question number 10. Of the cartoon produced by company, 5% have a puncture. 3% of the cartons, 5% have puncture, 3% have a smashed corner, and 0.9% have both puncture and smashed corner. See here, and this and that, so it's coming together. And smashed corner. Find the probability that randomly selected carton has puncture or smashed corner. All right, since already we are given probability, what is going to be? Since we have or, we are adding 5%, adding this 3% that we have. Here it is, because it says or, right? But we have 0.9%. Where was that? Here it is. 0.9% has both, which means I need to subtract to eliminate the duplicate, minus 0.9%. And that is going to give me 7.1%. Question number 11. You roll a 6-sided die. Find the probability of each of the following scenarios. Roll a 5 or See, here we have or, which means we are going to add a number that's greater than 3. So what's the probability of 5? So when we're dealing with probability, it doesn't matter 5, 4, or 3. It's what does matter, how many. So we have 5, which is 1. Probability is going to be 1 over 6, right? Because total we have 6. And then greater than 3, it's going to be a different story. How many we have greater than 3? 4, 5, and 6. 3 of them, right? So it's going to be plus 3 over 6. Okay, and since they are repeating each other, greater than 3, it's gonna, there is 5 also, right? And we separately found probability of 5. So I need to subtract 1 because this 5 is repeating. Minus 1 out of 6, and result is 1/2, which is 0.5. 0.5 means 50%. Next, probability of it's going to be 1 or 2 or 3 or 4 or 6. Each one of them has probability 1 over 6. That means I have 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6. And I will get 5 over 6, which is equal 0.83 or 83%. Now probability 4 or 1 or 3 or 5. So it's going to be 4 times, right? 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6. Why? Because each one of them is 1 time, right? There's 1, 4, 1, 1, 1 times 3, 1 times 5. So each one of them 1 over 6. Result is 4 over 6, or it's going to be 2 over 3. So, which is going to be 0.67 or 67%. Moving to question number 12. This is what we have, table. So let's read the questions. Find the probability that student is male or nursing major. So it says or, that means we need to add. So probability that student is male. Well, how much is our total male? This much. So it's going to be 1230 over total is 3,435, right? Out of total. This is our grand total. Next, says or. So I'm going to add. What is asking next? Nursing major. How much is my total nursing major? 693, correct? So I'm adding 693 over 3435 or 3,435. And what is interesting here? Look, when it's asking for male, student the male, here is male, right? Oops. Student is male, so it's going horizontally. Then I have nursing major, it's coming vertically. That's where it's repeating each other, 93, see? 93 people have nursing major and male, so 93 people repeat in this one and repeat in this one. Therefore, we need to do minus 93. It's similar to the previous problem when I said it's repeating. 3, 4, 3, 5. If you solve it, you get 0.498. Okay, so 0.498. For the B, find the probability. Let me clean this now. Find the probability that student is female. Now I'm going to go for female. 2325, right? 5 over 3435. Or not a nursing not a nursing major. So if it's not a nursing major, what is going to be? It's going to be this one, right? Not a nursing major. So total 2742 plus 2742 over 3435. And which one is repeating here? This number, 1725, right? Therefore, I need to subtract to eliminate duplicate. 5 over 3435. And the answer is going to be 0.973. How are you going to work with this fraction? Since denominator is the same everywhere, so you're going to take 2325 at 2742 and then minus 1725, and at the end divide by 3435. Very easy. That's the easiest way. So here we get 0.973. Moving to question number C. Find the probability that student is not female or nursing major. So we have here total female or male, right? In this table. If it's not female, if it says not female, then it means male, right? If I look to this case, A, it says male, or being a nursing major, which is going to be 0.498. Okay? Same question, it just, they redid it. Instead of saying male, it said not female. And there is only male and female. If it's not female, then it's going to be male. And D, it's going to be, are these events of being male and being a nursing major mutually exclusive? Are they mutually exclusive, which means they can't be male and nursing major at the same time? Let's see. Male and nursing major. Yeah, they can, 93 of them like that. Which means no, they are not mutually exclusive because 93 males majoring in nursing. Question number 13. So we have table here. Let's go answer questions. This is our total, grand total. So find the probability that the person opposed the change or is the male, female. So what how many people oppose the change? It's going to be 626, right? 626. Let me write down. So 626 over total 1060. Or is female. Where is my female? So this is oppose. Let me highlight it. And with this color, I'll go over female. It's going to be 569 plus 569 over, again, 1060 and minus this 307, right? It's overlapping each other. And oppose and female, so it's going to be minus 307 over 1060. So it's going to be 888 over 1060, and result is 0.838, which is 83.8%. B. Find the probability that persons support the change or is male. Let's clean this one. We leave only total. So the person support the change. Where is our support? It's right here, 392. 392 over 1060. Or, oops, it's 1060, or is male. Where is our male? Right here, 491. And 160 is repeating, right? So we do subtract 160 over 1060, and the answer is 0.682. C, what do we have? Is not unsure, not unsure. So we have 42. Let me clean this. We have total 42 unsure. And it says not unsure, which means what I'm doing, I'm taking 1060 minus 42. The rest will be unsure, right? If I take the minus unsure, will be, rest will be not unsure, over 1060, right? And then plus, it says or female, because it's or, we add it, and female, how much is our female is here? It's going to be 569 plus 569 over 1060, and minus how much we have? 569, it's female. It says not unsure or is female. So is female 569, and I'm going to do minus. So 569 minus this 30. Over 1060. Let me double check here. 1 second. 569 minus 30, and we divide by 1060. Okay. Yeah, because it's, we need not unsure one. Okay. I was double checking 569 minus 30. Why? We, in previous cases, we just would subtract 30, right? But here we do 569 minus 30. Why? Because it says not unsure. So female that is not unsure, we need to take 569 minus this 30. Or you can do 232 plus 307 and over 1069. Doesn't matter either way. Okay, and that is going to be equal practically 0.96 plus 0.537 minus 0.508 equals 0.989. So here is 0.989. All right. So our question number D, are the events being male and support mutually exclusive? Male and support, let's see. Let me clean this. Male, 160 people, and male and support. Okay, here it is. No, because there are 160 people that are male and that support the change. Okay. Question number 14. So we're gonna solve same way the question. I'll just fly over real quick. So what do we have? Frequently being involved. Here it is, frequently involved. Or being occasionally involved. Because we have or, we need to add. So occasionally involved, here it is. As you can see, they are not overlapping, so we are not going to subtract anything. So it's going to be, total is going to be 432 over 2862. This is our grand total. And then plus 889 is this, it's an occasionally case total, over 2862. And that is equal 0.151 plus 0.311. And the answer is going to be 0.462. This is going to be 0.462. Okay, B, find the probability that person is female or not involved. So it's female, we have female, and or, which is going to add, and not involved. Let me see. In charity, which one is not involved? Let me clean this. Female. Where is our female? Here it is. Horizontally. 1383. So we are going to have 1383 over 2862 plus not involved in charity is this one. Yes? 1541 plus 1541 over 2862 and minus, we're overlapping, minus 747 2862. If you solve it, it's going to be 0.761. 0.761. Question number C. Find the probability that person is male or frequently involved in charity. Let me clean this. So we have a probability that it's being male. Where is being male? Here is male. 1479, it's going to be 1479 over 2862 plus, because it says or, being frequently involved. Where is frequently involved? Here. Plus 432 over 2862 and minus, because we have here overlapping, 2226. Okay, minus 226, I'm sorry, over 2862, and the result is going to be 0.589. Okay, 0.589. Question number D. Find the probability that the person is female or not frequently involved. So female. Where is female? Let's clean this. Female, it's coming this way. 1383, let me write down, over 2862. And then not being frequently involved. So not being frequently involved. So frequently involved 432 total, not being frequently involved, I'm going to do plus 2862 minus, because it says not frequently involved, minus 432, or I can do 889 plus 1541, doesn't matter, over 2862. Okay, not frequently involved. So female and not frequently involved, we are talking about this one and this one. So we have two duplicates here, 430 and 747. So we are doing minus 430 over 2862 and minus 747 over 2862. And the answer is going to be 0.921. And lastly, are these events being female and being frequently involved, in charity work, mutually exclusive? No, they are not. Why? Because frequently is here and female is here. 206 are frequently involved and females here. Moving to question number 15. Determine the probability that at least 2 people in the room of 5 people share the same birthday, ignoring leap years and assuming, so 5 people share the same birthday, ignoring leap years and assuming each birthday is equally likely by answering the following question. Compute the probability that 5 people have different birthdays. So 5 people have different birthdays. So 5 people have different birthdays. What is going to be? So besides of first one, if the first one you don't know, different, not different. So we go from second one, because second can be equal to 1, right? And third can be equal to second one and first one. So probability of second birthday plus probability of third birthday plus probability of fourth birthday and plus probability of fifth birthday. Why? Because we have 5 of them, 5 people. Okay, so what is going to be a solution? Let me move it here. I'm going to get first one, it's going to be 365 over 365, right? Can be any, right? Oh, hold on. I messed up here. It should be multiplication everywhere. Because they can repeat, and first one and second one and third one, right? We can use the word and, therefore going to be multiplication. 365 over 365, because that's first person. It can be either way. The first person can have any day out of 365 days. And it's going to be gone anyway, that's why. But if it will make it easier to understand, I'll do this. I'll put equal probability of first one. Okay, didn't work. Let me put this way. Multiply. There we go. So you can understand better. So first one, I have all 365 days, either day to be birthday. Second one will have one more less, 364 over out of 365 days. Third one is going to have 363 out of 365. And then 362, because if days are taken, then will be left less, right? Because they said it cannot be repeated. 365, we have 1, 2, 3, 4, and one more, 361 out of 365. So this is gone. And if you multiply, if you solve it, it's going to be 0.973. Okay, for B, the probability that at least 2 people out of 5 share a birthday. At least 2. When we say at least 2 out of 5, so because here we're at least at the 2 out of 5, what we're gonna do? We're gonna take 1 minus this hour 0.973. It's gonna be 0.027. Okay, or it's a 2.7%. And the last question, which word is associated with multiplication when computing probabilities? And I talked about it. Okay, I'm done. Hopefully this will be helpful, and I'll see you in next video.